Okay, so now we're going to talk about the norpyrazole synthesis. So we're going to start off with a 1,3-dicarbonyl. So I'm going to write that here. Okay, so we have our 1,3-dicarbonyl. Sorry, that's a little. Okay, 1,3-dicarbonyl. Now I'm going to protonate. We have some acid hanging around, right? We have some catalytic acid. I'm going to protonate one of those carbonyls and make it reactive. So you can feel free to follow along at home. And you can check your work, see how good you're doing with what I draw out. It'll be like a little game. Did you get something similar? Okay, now we're bringing in our hydrazine. Okay, so I brought in my hydrazine. I've drawn it suggestively. So what's going to happen next is a nucleophilic acyl substitution. So we're going to attack. Right? And this is going to lead to one of the two substitution patterns. Remember, there's two substitution patterns. Right, so we got the alcohol now. We've got that hydrazine. We have this addition product. Yes? Now we've got that A- hanging around, so let's bring that in. I'm going to be really nice here and do some of the proton transfers explicitly instead of implicitly, which is kind of my thing. Okay, so now we have this substituted hydrazide here. We've got the hydrazine adduct. And let's bring in that HA again and protonate that alcohol. Follow along with at home with me. So, you can see what we're doing here. What we're doing here is we're forming an imine. We're riding through the steps of imine formation that you guys have done a number of times in this class, done a number of times in life. We talk about them a lot. They're important. You wouldn't be alive without imines, like we talked about in last lecture. A lot of your enzymes need imines. You're taking a cofactor that's going to form imines so that you can stay alive in your B complex vitamins. So now we have this. We're going to form that imine. Okay. We got R groups everywhere. I got something that looks like this. Yeah? Yes? You with me? Okay. And I'll be, again, nice. Throw in that proton transfer. Be real friendly like. Feel free to do this at home and then check yourself with my video. Bye-bye. Proton transfer. Okay, so now let's go ahead and work on that other carbonyl. So let's protonate that without HA. That was just deprotonating that protonated imine. Let's protonate the carbonyl. Now we're going to get this intermediate here where we've got the one carbonyl is now hydrazone and imine. Sorry, I left an H out on this previous. I hope nobody is having a heart attack over that. Okay. And so that's what that looks like, right? And now we have it suggestively, John, that we have this other nucleophilic nitrogen. We've got this protonated carbonyl, so that's going to have a little dipole here, right? This has got a nice delta plus. It's got a dipole going in this direction, right? And then we've got this nucleophilic nitrogen here. And we can form a 5-membered ring, so that's pretty good. So we're going to go ahead and do that. I'm going to draw it flipped over because I feel like it. Alright, so we can do something like this. See what I did there? I got that A- hanging around, so we can go ahead and deprotonate that nitrogen. And now let's bring in that HA again. We're eliminating water, which is a good thing, and we are driving towards aromaticity, another good thing. Okay, now we got that water. How are we going to eliminate it? Think for yourself. How are you going to eliminate the water? Just what you got? Good job. Now you're like, Rachel, this crap's not aromatic yet. What am I going to do? Well, be patient. We're not done yet. Not aromatic yet. What the hell? Well, we got that acid hanging around. Gotta learn how to calm down. Take things easy. Remember, you never knew what's coming. How many financial perspectives predicted there'd be a pandemic this year? None. And we get an aromatic product. Because, remember, we have that lone pair that's participating, right? So that lone pair is part of the aromatic system. And this lone pair, not part of the aromatic system. So this, part of the aromatic system, yeah, not part of the aromatic system. That is the norpyrazole synthesis. It's related to the norpyrrole synthesis.